Hello, my name is Michelle, and today we are going to take a look at finding the domain and range of this rational function right here. H of x is equal to 1 over x squared minus 9. So first thing we're going to do is start with the domain. The domain is simply going to be the set of all real numbers that are allowed to go into this function and will help us to output a real number instead of some kind of weird syntax error. So the domain, in this case, is going to be all x's that avoid division by 0. So x squared minus 9 may not equal 0. Solving this, of course, we get x squared cannot equal 9. Therefore, x cannot equal plus 3 or minus 3. So that was pretty simple. Therefore, in our set notation, we'll write our domain as a set of all x in the reals such that x is not equal to plus or minus 3. Now, we can also write this domain in interval notation. Anything that can be written in set notation can be written in interval notation, but in this case, writing this set in interval notation is a little cumbersome. Why don't you give it a try just for fun, but keeping in mind that if you find it's easier to express something using the set builder notation, then that's what you would use. So coming now to trying to find the range of this function, we know that that can be a little trickier, especially since it's not as algorithmic as finding the domain. There doesn't seem to be a formula for it. And in some cases, honestly, there isn't. So what we'll do is to find the range, we're going to examine the domain in sections and then see what happens to those sections when we put it through H. This is a similar method to the one that we discussed in class when we were dealing with the root function. So that's going to be examine the domain in sections. I know it's weird because little bits of myself are popping in and out of the video. Sorry about that. Just ignore it. All right, so the first section I'm going to look at is, I'm going to think about it as negative infinity to negative 3, not including negative 3, the open interval negative 3 to plus 3, and then the interval plus 3 to plus infinity, not including plus 3. So that's negative infinity to negative 3, not including either endpoint. So what happens to this? What is H going to do, basically? It's going to give us another interval that I can give you as a hint. So if you take a look at this leftmost area, H is going to take a big negative number. And what's it going to do? Well, looking back up here, you're going to sub in this big negative number, and then you're going to get it squared, so it'll stay big, but it'll become positive. And subtracting off a 9 really won't change that character very much. So you're going to get 1 over a really big number. And 1 over a really big number is going to go to 0, but it's from the right. Why from the right? Again, because we squared our negative number, and so we did get 1 over a really big number, but it was a positive number that we ended up getting, a very small positive number. So take some time, think about it, unless you get it. If you get it, good. Let's continue. What's going to happen when we come closer and closer to this endpoint? Well, we come closer and closer to this endpoint, then we will say we could actually plug in something like negative 3.001 just to make it easier on us. So we'll end up getting something like, this is 1 over 0.006. 1 over a very positive small number. What is 1 over a very positive small number? It's going to equal a positive big number. So this is going to approach infinity as we approach negative 3 from the left. So it almost takes this interval to this interval 0, infinity, but does it do it backwards? No. It seems to kind of have a nice ordering to it. Now, interestingly enough, when you plug in 0, 0 is not in here. Never mind. Okay, just kidding. So this is what we get here. I was thinking about 0. 0 is a good number to test, but 0 will be in our next interval. So we'll look at that then. So just give it a quick pause because I have to deal with this board thing that won't erase well unless I spray it every time. Take this opportunity to fast forward or procrastinate by watching this whole event. There are worse ways to procrastinate, right? There we go. All right. So for the range, we know that negative infinity, negative 3 is going to get mapped to 0, infinity. And then for the second interval that is part of our domain, we're going to look at negative 3 to 0, and we're just going to stop it there. I was thinking of going negative 3 to 3 because that's what I said, but now in the middle of this whole thing, I'm thinking, well, 0 is actually a really important point, and I don't want to minimize it by just looking at the interval negative 3 to 3. So this idea that I had before, we're not going to do that. We're going to just try to include 0 as an endpoint as much as possible when examining the range this way. And of course we can put 0 into the function. It's part of the domain. Now, what is h going to do in this case? It's going to take us to another interval. So we'll examine what happens when we plug in something really close to 3, but that lies in this interval. H at negative 2.999 is actually approximately equal to 1 over negative 0.006, which looks kind of familiar, I guess. And so what's going to happen is you're going to start forming these larger and larger but negative numbers. So as you continue getting closer and closer to this endpoint, in your range is going to accumulate all of these negative big numbers. So we are going to end up going to negative infinity. 1 over really small number is a big number, right? And then let's check h at 0 since we decided to just cap it off there, and you get minus 1 over 9. Now, when we examine taking the interval 0, 3, which is kind of the remainder of the middle interval of the domain, it does the exact same thing. So h is going to take this interval to negative infinity, comma, minus 1/9, square bracket on the minus 1 over 9, just the same as this would here. So b and c are the same. It's almost like it spits out these numbers twice. And if you look at a graph of it right now, you'll see why. If you choose not to and just pursue it algebraically, that's a good idea too. And you can check a graph when we're done. The only other thing to do is to look at that one other section of the domain that we haven't discussed yet, which is starting at 3 and then going to negative infinity. This is kind of tedious, but you're going to start seeing a lot of repeats of items in the range. So we already know that this happens. And the analysis of the b and c middle type intervals of the domain are giving us that this is happening as part of the range, for lack of a better statement. So just bear with me one more time while I do this. Again, go check your text messages. All right, there we go. So take some time to process then that number 1, I foolishly accidentally erased my first interval. So let me write that again. Oh my goodness, why? There we go. And then we have that b and c. We have, let's see, it was minus 3 to 0, or 0, 3. It's going to get taken to negative infinity minus 1 over 9. So now our range is all positive numbers, almost all negative numbers, but kind of stopping at minus 1 over 9. The last thing to do is examining the domain interval 0 to, no, just kidding, 3, infinity. And h is going to take that to, okay, so you do an analysis. Do it now. Think about what happens if you put in something like 3.001, even try it. Think about putting a really large positive number downstairs, and what you'll end up finding is something very similar to what happened for our first analysis. This was our first analysis, and we ended up getting this. And in fact, this happens again. So why is that? Weird. Can that happen? Of course it can happen. It just so happens that this function is not one-to-one or injective, as it's called. We'll learn that later. Some functions just do that. Different parts of the domain will create duplicates of the same part of the range. It's all very interesting. So think about that a little bit. What I'll just do is turn my page, a little noisy there, and I'll say therefore the range of h will be written below, and it's going to be all real y, such that either y is less than or equal to -1/9, or y is strictly greater than 0. And of course you may use intervals to denote that as well. I just chose to use my set notation, but we could say the interval -infinity, -1/9, included, unioned with the interval 0, infinity is going to give us our range. Almost everything, but a couple of things get left out. So do a graph of this using technology if you want and see if this makes sense. And definitely take some time to review any parts that don't make sense, and feel free to email me with any further questions. I will save you the tedium of having to watch me erase the board one more time. Thank you for watching.